Alright, so section 4 here deals with complex numbers. Before we get into the complex numbers, just some things about square roots. If you're dealing with the square root of 9, that would be 3. When you have something like the square root of 20, you can factor that to 4 times 5, and then the square root of 4 is 2, and then the square root of 5. Another way to look at it is if you didn't know that there was a square root for 4, you would factor 4 down to 2 times 2. And then because it's square root, you have a pair of 2's that get to go outside of the square root symbol as a 2. And then the 5 has to stay underneath. So then, getting into square root of a negative 1, that is I. It stands for an imaginary number. And so then, since the square root of 9 is 3, the square root of a negative 9 would be the same as the square root of a negative 1 times 9, which is the same as the square root of a negative 1 times the square root of 9. And the square root of a negative 1 is I, and the square root of 9 is 3. And so the square root of a negative 9 is 3i. Similarly, with the square root of a negative 20, that would be like the square root of a negative 1 times the square root of 20. And the square root of a negative 1 is I. And then you would have 2 times the square root of 5. Now you may write it like this, or you may write it as 2i times the square root of 5. Either way. Just be careful when you do write, if you do write it this way here, that you do not put the square root over the I, because the I is outside of the square root. Then if you take a real number and you add or subtract an imaginary number from it, you get what is called a complex number. A complex number is in the form of a plus bi. A is your real number, bi is your imaginary number. The b part is a real number though. But this whole thing is called the imaginary part. And every real number can be written as a complex number as well, because like the number 5, if you were to write it as a complex number, would be 5 plus 0i. Why you would want to write it that way is beyond me, but it is an option. Another example of a complex number would be something like 3 plus 2i. Or you could have something like 1/2 plus the square root of 5i. And if you had just plain old 7i, that is called a pure imaginary number. And if you were to write it in complex number form, it would be 0 plus 7i. And because these are numbers, all of the different operations can be done with them. If you are adding, just like with variables, you add similar terms. So you would take the 2 plus the 3, and you would get 5. And 5i minus 6i would be a negative 1i. Subtracting then, do the same thing, 2 minus 3, which equals a negative 1. And then 5i minus a negative 6i, which should turn into 11i. Now when multiplying, it's just like if you had x plus 2 and x minus 2, you have to distribute. The 2 has to be multiplied by both things first. So 2 times 3 is 6, and 2 times a negative 6i is a negative 12i. Then you would have 5i times 3, which is 15i. And then finally, you would have 5i times a negative 6i, which is a negative 30i squared. because I times I is I squared. And negative 30i squared is the same as I times I, which would be the square root of a negative 1 times the square root of a negative 1, which is just negative 1. And so this would be a negative 1 times a negative 30, so it turns into positive 30. And then combining like terms, 6 and 30 would get you 36. Negative 12i plus 15i would be plus 3i. And finally, if you had to divide, you would first write it as a fraction, 2 plus 5i over 3 minus 6i. And just like with square roots, you cannot have an I in the denominator, so you have to multiply both the numerator and the denominator by 3 plus 6i. These two things are called conjugates. Where the first term stays the same as they're here, and the second term becomes its opposite. And so then you have to multiply all of this together. So 2 times 3, 2 times 6 would be 6 plus 12i, and then 5i times 3, and 5i times 6i, which would be plus 15i, and plus 30i squared. And then that is all over, and then multiplying the bottom, distributing the 3 first would be 9 plus 18i, and then also 6i times 3 and times 6i, and a negative 6 times 3 would be a negative 18i, and a negative 6i and a positive 6i would be a negative 36i squared. And then again, because you have I squared times a negative 36, that turns into plus 36, and positive 30i squared turns into a negative 30, because I squared is a negative 1. So then combining the things that you can, 6 and a negative 30 would be negative 24. 12i and 15i would be plus 27i. And then 18i and a negative 18i is 0, is 9 plus 36 is 45. Now then, if you were to write this in complex number form, you can't leave it like this, so you'd have to put negative 24 over 45 plus 27 over 45i. And then that can be simplified even more, because 3 will go into that negative 8 times, and into that 15, and then plus, and 9 will go into these two things, so 9 goes into 27 3 times, and into 45 5 times. And so here is your answer when dividing. Last thing for today, oh actually there's two more things. When you're multiplying with square roots, with this you just multiply what's underneath. Square root of 5 times square root of 6 becomes the square root of 30. When there's only one of them that's negative, it really doesn't matter how you do this. You can multiply the two things together and get square root of negative 30, which then in turn becomes I times the square root of 30. And you can't simplify the square root of 30 because that is only 3 times 10 and 2 times 5, and there are no pairs of anything here to take it out, so we just leave it that way. But when you get to something like this and you're multiplying, if you just multiply this times this, you will get the incorrect answer, because that would turn into the square root of a positive 30. But that is not correct, because what you actually should have done here in this one even, but it doesn't matter because there's only one negative, but with this, it should have been turned into I times the square root of 6 first, before you get to multiply by the square root of 5. And then that turns into that answer. So with this one, we would have to first convert this to I times the square root of 6, and this would turn into I times the square root of 5. Now when you end up multiplying, I times I is I squared, and then you still have the square root of 30. And then because I squared is a negative 1, it turns into a negative square root of 30. Last thing for today. Dealing with the different forms of I and with each power of I. So we know that I to the first power is like the square root of a negative 1. If you take and square that, that's the square root of a negative 1 times the square root of a negative 1, which is just going to be negative 1. If you take I to the third, that's the square root of a negative 1 times the square root of negative 1 times the square root of a negative 1. Well, these two turn into a negative 1, and then you still have the square root of the negative 1. Or you can say that is a negative I. And then I to the fourth is like the square root of a negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. And these two turn to plain I. And those two, when you multiply, are both I. No, that's not right. What did I just say? They don't turn into I. Looking at the wrong thing. Square root of a negative 1 times the square root of negative 1 is a negative 1. And then the square root of a negative 1 times the square root of negative 1 is also a negative 1. And then when you multiply those, that becomes 1. And now, if you go on further and talk about I to the fifth, that's like saying I to the fourth times I. And we already know that I to the fourth is 1. And 1 times I is I. So I to the fifth is the same as I. If you do I to the sixth, that is the same as I to the fourth times I squared, which is going to be like this one here. It's going to be a negative 1. I to the seventh would be this. I to the eighth would be 1. So this is, and you can continue this as a pattern forever. So then this would be to the ninth, to the 10th, to the 11th, and the 12th. 13, 14, 15, 16. So anytime you're dealing with I to some power, if it is an even power, then you're either going to get a negative 1 or 1. If it's divisible by 4, it's 1. If it's only divisible by 2, it's negative 1. The odd powers, then you are either going to get I or a negative I. And you just have to figure out which one it is, depending on if you divide the thing by 4 and whatever the remainder is, that's where you would be. So like for example, if you were asked what is I to the 23rd power, well, that's like I to the fourth times I to the fourth times I to the fourth times I to the fourth, and there's 4, 8, 12, 16. There's 20, and then you have I to the third left. These are all 1, and then it's I to the third, which is negative I. And so you'd get a negative I to this one. Now, so that you don't have to go through that whole big process, if you just take 23 and divide it by 4, that's 5 and with 3 left over, so that's just like the same as I to the third. If you were trying to find I to the 21st power, 21 divided by 4 is still 5, and then there's 1 left over, so that's like I to the first power. If you were trying to find I to the 28th, well, when you take 28 divided by 4, that works out evenly, so therefore it is 1. And if you had I to the 26th power, well, 26 divided by 4, it doesn't go in evenly, so then there's 2 left. That would be a negative 1. And that concludes your lesson for today. So you should start working on section 2.4. Tomorrow, like I said, we will take questions on both sections 2.3 and 2.4. And Friday, we will be moving on to 2.5. Have a great rest of the day.